Hey guys, welcome to Conceptual Geometry, Lesson 4.6, Reflection Rules Continued. This is not in your notes. I just want to take a few minutes to go over our reflection rules from the last lesson. And this is kind of a nice order for you guys to memorize these. I start with reflecting in the x-axis, then go to y-axis, reflecting the line y equals x, then the line y equals negative x, and then the origin. So for reflecting in the x-axis, I like to remember the saying, negate the y, or negate y. So if you can remember that, this becomes x negative y. Reflecting in the y-axis, I remember the phrase negate x. So xy reflecting in the y-axis becomes negative x positive y. Reflecting in the line y equals x, since those two are equal, that is switch. So xy becomes yx. Reflecting in the line y equals negative x, we switch and negate both. So this is a switch and negate both. So xy becomes negative y, negative x. And our last one, reflecting through the origin, we negate both. So xy becomes negative x, negative y. So that's kind of what we went over in our previous lesson. We're going to use that today. Okay, now let's jump into notes here. It says graph segment AB if A is 0, 2. So 0, 2, we're going to put a point there, label that A. B is 2, 4, put a point there, label that B, and then connect it because it's a segment. Now the directions say, state the coordinates of A prime, B prime, the image of AB after a reflection in the y-axis, reflection in the line y equals x. So if you remember, the line y equals x looks like this. So what some of you might want to do is you would lightly sketch in this line and you would do a visual job of reflecting. So A prime would go here, B prime would go there, and we're going to sketch it in like so. Others might want to use this rule here, reflecting the line y equals x. Oh, I just switched the coordinates. And you would actually write the coordinates down first. So A prime and B prime, what would those coordinates be? Well, for A prime, I'd have to switch these two. So it becomes 2, 0. For B prime, I'd have to switch those two, so it becomes 4, 2. Now, once we have those, I could plot them. So A prime is 2, 0. B prime is 4, 2. And then just connect them. That is the exact same image we had if we were visual and sketched in that line and reflected visually. So there's two approaches you can take here. Next it says, state the coordinates of PQ, which is the image of A prime, B prime. So we have two images. We have AB here, we have A prime, B prime here. We're taking A prime, B prime. So I'm taking this one, and I'm reflecting it in the x-axis. So here's your x-axis. You can be visual and say, well, that's going to stay there. This will get reflected down there. All right, and we're just going to switch up the letters a little bit. We're going to call it PQ. Or you can use your rules. So what we're doing here is we are reflecting the x-axis. So let me flip back here. Reflecting the x-axis, you can remember it's x negative y, or you can remember the saying, oh, I just negate y, which is usually how I do it. Reflect in the x, negate the y. So what I would need to do is I would need to take these coordinates here, because those represent the coordinates of that segment, and negate the y. So if you negate a 0, guess what? It just stays 0. If you negate 2, it becomes a negative 2. So that becomes 4, negative 2. And then we can plot those points. P is 2, 0. Well, that's the same as A prime. Q is 4, negative 2. And then you connect that segment. Okay, and there's one more part here. State the coordinates of JK, the image of AB, after reflection through the origin. So again, I've got three shapes here. I've got AB, I've got A prime, B prime, and I've got PQ. I'm taking AB and reflecting this through the origin. All right, so I'm running out of colors to use here, but if I reflect through the origin, well, let's use some rules. So this will be JK. I have to go back up to the beginning, so I'm using these coordinates. And let's go back, reflecting through the origin. Oh, I negate both, negative x, negative y. So let's take these coordinates and negate both. So that negating a 0 stays a 0. This becomes 0, negative 2. And this would become negative 2, negative 4. Okay, so let's plot those. J is 0, negative 2, so there's J. K is negative 2, negative 4, there's K. And you connect those endpoints to get that segment. So I've kind of graphed as I've done this. I'm not a big fan of the way that this is ordered, so we've already done this. We've taken care of it. This is always how I would prefer you to do it as well. Do the graph and the coordinates, or the coordinates, then the graph, one right after the other. So we have our picture right here of all of those segments. Okay, let's try another one. This time, we have to graph the original shape. So it says here, graph triangle ABC if A is 1, 1. So let's plot that point. There's A. B is 3, 2. So there's B. And C is 2, 5. There's C. And we're going to sketch that in. If you've got a straight edge, this would be a great application for it. Now the directions say graph and state the coordinates of A prime, B prime, C prime, which is the image of triangle ABC, after reflection in the x-axis. So by now, hopefully we understand reflecting in the x-axis is negating the y. So I'm going to take these coordinates here, and I'm going to negate the y. I'm going to write those coordinates out. A prime, B prime, C prime. Negate the y. So this is 1, negative 1, 3, negative 2, and 2, 5. Sorry, 2, negative 5. And let's plot those points. A prime is 1, negative 1. So there's A prime. B prime is 3, negative 2. There's B prime. C prime is 2, negative 5. Now, remember, visually, what are we doing? We are reflecting in the x-axis. So I'm taking this triangle here. I'm reflecting it in this axis. What happens? Well, it gets reflected down to this one. So it should make total sense when we're done. These two triangles should be the exact same size and shape, and they are. Okay, next. Graph and state the coordinates of triangle A double prime, B double prime, C double prime, which is the image of A prime, B prime, C prime. So I'm using this triangle, these coordinates. I'm taking those, I'm reflecting in the y-axis. Well, reflecting in the y-axis means we negate x. So I'm going to take all of these coordinates and negate the x for each one. Okay, so that'll give me A double prime, B double prime, C double prime. Negating the x, I get negative 1, negative 1, negative 3, negative 2, negative 2, negative 5. And it's actually pretty quick because I'm just looking at these coordinates right here and just putting a negative in front of the first number. Well, let's plot those. A double prime is negative 1, negative 1. So there's A double prime. B double prime is negative 3, negative 2. There's B double prime. And C double prime is negative 2, negative 5. C double prime, sketch in that triangle. And when we're done, this should make total sense. I'm starting with this triangle here. I'm reflecting it in the y-axis, and it should go over to this one. And again, they're the same size and the same shape. Now, the next question is kind of interesting. It says, what single reflection? Well, we've got 5 choices: x-axis, y-axis, y equals x, y equals negative x, and the origin, would result in triangle A double prime, B double prime, C double prime being the image of triangle ABC. So here's what they're saying. Okay, if I start here, how do I end up here in one shot? Well, I think that's pretty obvious. We go through the origin. That's called a reflection in the origin. So we use a little r for reflection and write out the word origin. All right, cool. The last thing we're going to do today, this is a little bit challenging. They're going to have us do two reflections in different orders. And notice they don't give us a graph here, so they want us to use the rules exclusively. It says, find the coordinates of A double prime, B double prime, which is the image of AB, if A is 1, 3, and B is 5, negative 2, after each. A reflection in the origin, then reflecting over the x-axis. All right, so let's start with writing the original coordinates down. A is 1, 3. B is 5, negative 2. Now, to show that we're going to reflect in the origin first, here's the notation we use. We use an arrow to indicate a mapping. So we're transforming these. And then we use the correct notation. So it's a little r with the word origin. And then this will be A prime, that'll be B prime, and I need to get those coordinates. So what we need to remember, reflecting in the origin means we negate both. So we have to remember those rules, which basically means put a negative in front of those, negate. If it's negative and you negate it, it becomes positive. All right, so this becomes negative 1, negative 3. This becomes negative 5, 2. All I did was negated both of these. Now, after we reflect in the origin, then we reflect in the x-axis. So now I'm taking these coordinates, I'm going to reflect in the x-axis. So let's write that out. Use your arrow because you're transforming, and then r, x-axis. And then this will become A double prime, B double prime. So again, remember our rules. Reflecting in the x-axis means negate y. I'm taking these coordinates here, I'm going to negate the y in each one. So A double prime becomes negative 1, 3, and B double prime becomes negative 5, negative 2. All right, so that first part is done. Now what we're going to do is we're going to go back to our starting point, AB. Go back here. But now we're going to reflect over the x-axis first. So it's going to look very similar to this, except we're changing the order. This is going to be over here, so we'll have different coordinates here. And then my reflection in the origin will be there. And at the end, we'll see, do I get the same result? Do I get a different result? Let's find out. Again, we have to show all our work, so we start with A, which is 1, 3, B, which is 5, negative 2. And I'm going to reflect in the x-axis. So we've already mentioned this. Reflecting the x-axis means you negate y. So I'm going to negate those right there. So A prime is going to be 1, negative 3. B prime is going to be 5, 2. Then I reflect in the origin. And review, reflecting the origin, negate both. So I'm going to negate both of these. And let's see, I get A double prime. If I negate both of those, that's negative 1, 3. B double prime, negate both of those, is negative 5, negative 2. Are the two compositions equivalent? So I know we have a different middle step here, but we're not really comparing the middles. Do we end in the same location for both? So compare coordinates. Yeah, they're the same. So that answer is yes. And the last one, a little bit more challenging. It says, what single transformation is equivalent to the composition of the point reflection through the origin, followed by reflection in the x-axis? So let's kind of ignore this middle step. How do we go from here to here in one step? Well, let's compare what's different. 1, 3, 1, 3. I didn't change the order, but notice 1 became a negative 1. So it looks like I negate x. And remember, when we negate x, that is a reflection in the y-axis. So those questions are a little bit more challenging. Okay, great job, guys. Thanks for following along. As usual, if you have any questions, don't hesitate to reach out, and we'll see you in class soon.